Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 5.1 on solving systems of linear equations by graphing. And I know what you're thinking, because you're thinking that you hate graphing. Oh, well, that's too bad because we're going to have to do it anyways. And we're going to ask the essential question, how can we solve a system of linear equations? So this is the first method we're going to do. You need to see what it looks like when we're graphing. We'll do some other methods later on in this section. But for right now, let's talk about some definitions. We've got two definitions we want to make sure that we know. First of all, what is a system of linear equations? Well, it is a set of two or more linear equations in the same variables. So this is important. And typically what we'll be dealing with is two linear equations with two variables, x and y. Two equations, two variables. Next, we have a solution of a system of linear equations, and that's going to be an ordered pair, 1x, 1y, right? An ordered pair, 1x, 1y, that is a solution of each equation in the system. Okay, go ahead and pause the video and get these into your notes, and then when you're ready, join me on the next screen. So the first type of question we have to ask is whether a given ordered pair is a solution to a given system of linear equations. And this is quite easily done just by substituting. Okay, so here I have x and y, 2 and 5, and I've got these two equations. So you notice we have an x and y in both of these equations. Right? So we have a system of equations, two variables, x and y, two equations. Okay, so let's go ahead and substitute in equation 1. X plus y equals 7. Well, it's going to be 2 plus 5 equals 7. And simplifying the left side, 7 equals 7. So we like that. For equation 2, 2x minus 3y equals negative 11. So 2 times 2 minus 3 times 5 equals negative 11. Okay, we'll use order of operations on the left-hand side to simplify. 2 times 2 is 4, and 3 times 5 is 15. So I've got 4 minus 15 equals negative 11. And then 4 minus 15 is indeed negative 11. So negative 11 equals negative 11. So we like that in 2. That's a true statement. So since 2 and 5 work for both of these equations, then 2, 5 is a solution. It's really the solution. There's only one solution for the system. Okay, let's check out example B here. And again, x is negative 2 here, y is 0. Now these are written in a different form. These are written in slope-intercept form, right? So y is 0 equals negative 2 times negative 2 minus 4. So 0 equals negative 2 times negative 2 is positive 4 minus 4. And then 4 minus 4 is 0. So that works. And let's check negative 2 and 0 on the second equation here. So 0, that's my y, equals x, which is negative 2, plus 4. So, excuse me, negative 2 plus 4 would be positive 2, and this is not true, so we don't like that. So since negative 2, 0 does not work for both of them, it is not the solution. It's only a solution for the first one, but not the second one. So negative 2, 0 is not the solution. Okay, so let's go ahead and take a look at what we mean by solving this by graphing here. So take a look at this page. You'll see that we've got a solution that 2, 5 works for both of these. What is that going to look like on the graph? In order to solve a set by graphing, we're going to graph each equation in the same coordinate plane, and then we're going to find the point of intersection. And this is really the key here, this point of intersection. Because that point of intersection is the point that's on both lines. That is the ordered pair that works for both equations. Okay? So here we go. Y equals negative 2x plus 5. I'm going to do this one in red, I think. Negative 2x plus 5. My y-intercept here at 5. My slope is negative 2, so I'm thinking negative 2 over 1. So down 2, 1 to the right, down 2, 1 to the right. So getting a bunch of lines here. So I'm going to use the magic markers on this thing to make this a little bit easier for me. You have to do it by ruler, but you want to make sure you do a good job of like lining up your line through all these points here. I can see I'm a little bit off there. Okay, that looks pretty good. Equation 2, y equals 4x minus 1. So my y-intercept is negative 1, right there. And my slope is positive 4. So up 4, 1, 2, 3, 4 over 1. And I can already tell that's going to be my solution. 1, 2, 3, 4 over 1. And let's go ahead and I can draw this using these lines like this. Okay, so there's our graph of the system. The solution is the point that is on both lines, which is right there. So my solution is going to be 1, 3. Just like that. That's my solution. And that's it. We've got some word problems we'll go over in class, but that's the basic parts of this lesson on solving a system of equations by graphing. Thanks a lot and have a great rest of your day. I'll see you in class. Bye-bye.